With towering volcanoes, swirling dust storms, and plumes of sublimating dry ice at its poles, the surreal landscape of Mars has captured earthly imagination for centuries. But what would it take to make it habitable? As in, a place where we could breathe, walk around without our blood boiling, or even grow crops and enjoy blue sunsets. There have been some wild proposals about how to make Mars more suitable for humans, from nuking the poles to hijacking a fleet of comets in order to kickstart a new climate. So how close are we to terraforming Mars? Terraforming is a term that was coined in science fiction, but today the idea is being thrown around by a handful of actual scientists.
Terraforming, put simply, is changing the atmosphere and climate of a planet so that it can support human life without the need for spacesuits.
To survive on Mars, that is, without extensive equipment and resupply from Earth, we need to be able to do a few simple things. Breathe, stay conscious, and not freeze to death. If we can figure out those 3 hurdles, we'd have the luxury of worrying about longer-term concerns, like how to grow food or shield ourselves from radiation. True, Mars doesn't sound that hospitable, but after multiple missions, we found clues that this wasn't always the case.
We see evidence that there was liquid water running over the surface of Mars. The atmosphere must have been thicker so that greenhouse trapping of heat from the sun would warm the planet and allow liquid water.
Most of Mars' atmosphere escaped to space over the last 4 billion years.
To restore it to a version that's more livable for humans, we'd have to address breathing first. On Earth, we have a delicious atmosphere made of around 21% oxygen, 78% nitrogen, and a little bit of everything else.
It wouldn't need to be exactly that mix, but we would need a very similar amount of oxygen. But there certainly is enough water locked up in ice on Mars to get some O2 for you. And unfortunately, there probably isn't enough nitrogen that we could easily get to build up an Earth-like, mostly nitrogen atmosphere. If you're willing to wear, like a gas mask, then the gases could be pretty much anything which isn't corrosive or acidic. You have to carry oxygen on your back. That could be an intermediate step.
Okay, fine. I'll agree to wear a DJ Marshmallow mask for a little while if I could skip the spacesuit. So that brings us to our other goals, staying awake and warm. And it turns out these two actually go hand in hand. If you stepped outside on Mars today, you'd pass out instantly and die shortly after, as the low pressure literally pulled the oxygen out of your blood. Temperatures on Mars sit, on average, at a chilly -63 degrees Celsius. But if we could thicken the atmosphere by adding some mass to it, we might be able to kickstart a greenhouse effect that would stabilize the temperature and stave off some of that deadly radiation as well. That's the essence of terraforming.
So the question becomes, is there enough CO2 anywhere on Mars that we could mobilize it and put it back into the atmosphere?
In terms of the very first sort of easy baby steps of terraforming Mars would be the release of the kind of easily accessible CO2. Now, this is the south pole of Mars here. It's kind of hard to see there, but it's some water ice, but mostly the CO2 ice down here. If you started making the planet warmer, you would sublimate more of it, or you could just nuke it.
The fast way is drop thermonuclear weapons over the poles.
That would only double the atmospheric pressure on Mars. So we would go from 6% of the Earth's atmosphere to 12%. And that's so not enough to heat up the planet.
Other sources of that desirable atmosphere for terraforming could be hiding in Martian minerals and dust, but they're tricky to unlock.
Carbon-bearing minerals have to be heated up to several hundred degrees, so you'd have to strip mine the planet globally in order to mobilize that CO2.
Mars has 140 trillion square meters. So that's about 1,000,000 billion tons of gas that we would need dug up out of the ground and then vaporized or somehow released from those minerals. And the energy required to do that is staggering. You'd need the equivalent of running 10,000 gigawatt nuclear power plants constantly for 10 to 40,000 years.
Now, we might be able to use something more efficient, a super greenhouse gas like hydrochlorofluorocarbons, for example. But we need to build hundreds of factories on the planet's surface to pump out enough of it to affect the climate. Then, of course, we'd have to add back in our custom cocktail of gases, to allow us to take off our gas masks and oxygen tanks, let alone grow any crops. So let's investigate our next option, stealing the building blocks of an atmosphere from comets.
There is a large source of nitrogen, oxygen, hydrogen, etc. in the form of comets. If you could redirect something like, depending on how big they are, 10,000 to 1,000,000 comets, and you were able to crash them into Mars on purpose, that would be possible given the sort of distribution of comets that we have now.
If you've got 1,000,000-kilometer-sized objects hitting Mars, that would be pretty damaging. It would probably devastate the entire surface.
But really what you would need would be an army of self-replicating robots that could essentially attach what people call mass drivers, which would be, let's say, a nuclear power plant on a comet, which could be fed by the water of that comet, and then would use that same water as propellant to act like a rocket, and over the course of years, redirect those comets to eventually impact Mars.
Sounds like some pretty heavy lifting. But with a new global enthusiasm for space exploration at lower costs, we might see some of the technical advances required to inch us closer to this vision, like autonomous navigation and in-space assembly of spacecraft, sooner than we think. But even if we can build and master all of this technology, should we charge forth in aggressively tailoring the solar system to our species' comfort zone? And how much should we promote the idea of having a spare planet in our backyard?
The danger in doing that is that we then think that we can muck up the Earth and we have a place to go. Given the difficulty of terraforming Mars, it's always going to be easier to keep the Earth's environment habitable, to repair any damage we do, than to fix Mars.
So, while we work on making sure our own planet's climate is livable, all we need to do to fix Mars up is figure out how to create legions of artificially intelligent robots, which can create copies of themselves out of Martian dust to help set up major mining operations and vaporize 1,000,000 billion tons of rock. Or we could build hydrochlorofluorocarbon factories, or we could capture, redirect, and crash land 1,000,000 comets onto the planet's surface without completely obliterating it. So how close are we to terraforming Mars?
Today, the emphasis is on getting a first human mission, and even that is really hard and really expensive.
Then we need to establish a scientific outpost to show that there's some level of sustainability on Mars as it is today, because we need to learn how to live on Mars as it is today before we can even begin to think about terraforming. The difficult part for me is seeing how we get from the scientific outpost, the sort of 10 or 20 or 30 people, up to the kind of 10,000 people that it would take in order to really start the terraforming project.
And that really requires a city on Mars. Is that 100 years into the future? 500 years? To my mind, anything beyond 30 years into the future is science fiction.
I think the people who ultimately terraform Mars are going to be Martians. They will have been adapted by generations upon generations of living in lower gravity. They'll be a lot taller than us. They might have different blood chemistry. They will ultimately start to diverge somewhat as a species from us, and evolution will slowly take over, and they're still going to be humans. They're still going to look like us, but they'll be different enough from us that they'll be easily identifiable as like, oh, that's an Earther, that's a Martian.
Mars might be a long shot, but you can orbit Planet Seeker by hitting the subscribe button right now. Let us know what you want to learn about next in the comments below, and thanks for watching. See you next time.